Hello, hi everyone, good afternoon. My name is Dr. Akash and today we are going to learn about acceleration. So I hope you were there in the last two episodes. If not, go back and watch the earlier two classes. Okay, so let's begin. This is about me if you are seeing me for the first time. So I have a PhD in physics from Singapore, BSMS dual degree from ISA Pune, as ranker in JEE Advanced and also KUPY. Hi Sachin, Kavita, Mad Screamers, Tabish, Uzzamaki. Nice. Sudhir. Hi everyone, good afternoon. So let's begin. So in the last class we have learnt what is velocity. Do you remember what is velocity? So velocity is a vector quantity. Miss Lovely Singh, good evening all. Sakina, hi, good evening. Ansh, I'm Harshit. Hi Harshit. Harsha, hi. Aisha, wow, so many new students. Nice to have you all here. Pradeep, good afternoon. Alright, so now in the last class we have learned what is velocity. Velocity is nothing but a speed in a certain direction. Velocity is a vector quantity. So for example, if I say there is a object and this object is moving in this direction, there is a particular direction with some speed and the speed is, let's suppose, 10 meters per second. So this will be the magnitude of the speed or the velocity and there is a direction. So if you combine these two, magnitude as well as direction, then you get the vector quantity, that is our velocity. Hi Rolex, good evening. Harsha, good evening. Yes, correct. Nice Harsha. Ayush, yes, correct. Awesome. So now we are going to learn about rate of change of velocity. So if the velocity is changing with time, so in which situation does it change? If it is a non-uniform motion. So in the non-uniform motion, what happens? The velocity will change with time, right? So that change in time is called as acceleration. So rate of change of velocity is called as our acceleration. Clear? Good evening. All right. Nice. Yes. Hi Siddharth. Good afternoon. Good evening. So now you see here this ball is moving at a very slow rate. It is just dropping from this point. So earlier initial velocity is almost zero, but as the ball is coming down, what happens? The speed will keep on increasing. Why? Because there is an accelerated motion. So what acceleration does? It increases the speed, right? That is the acceleration. We are going to learn when acceleration can also slow down the speed. So wait for a couple of minutes. Yes, we are going to learn all these different cases. RB, we are going to learn all this. You are the best, sir. Okay, thanks Ayushi. Ansh Patel, yes, it is a vector quantity. So similarly, velocity is a vector quantity. So even the acceleration is a vector quantity. And how it is written? Okay, before that, let's understand. We have learned in the last class what is uniform motion and non-uniform motion. So in the uniform motion, what was the uniform motion? In the equal intervals of time, the distance covered is equal. That was the uniform motion. If you plot it, there is a straight line. So in the uniform motion, the rate of change of velocity. What is the rate of change of velocity? Can you tell me? How to crack JEE mains? Which grade are you, Harsha? If you are in the foundation right now, like 9th or 10th, then like start studying, start doing a foundation practice. That is, don't look for JEE right now. You can start with the NTSC or the Olympiad kind of exams. And by that method, your foundation would be stronger. And once you go to 11th, then focus on JEE. Alright, 9th. So you should now focus on your NTSC type exams, NTSC or Olympiads exams, right? Because JEE like too far right now. If you start studying, you would get lost in between. So keep a smaller goals like Olympiad or NTSC would be. You should focus on cracking the NTSC exam right now. Alright. Yes. So rate of change of velocity in a uniform motion. If it is a uniform motion, what is the rate of change of velocity? It is nothing but slope of this graph. So that means, okay, sorry, not this graph. If it is a uniform motion, then there is no change in the velocity. So what is the acceleration? So in that case, acceleration is going to be 0 for the uniform motion. So whenever you say a uniform motion, what will happen? The acceleration value is 0. That means the velocity is not changing with time. Clear? Don't eat it, okay? Anesthetic shots, don't eat anything. Alright, velocity is constant. Yes. So if the velocity is constant, change in the velocity is 0. So if it is non-uniform motion, what will happen? Non-uniform motion means the speed of the object is changing with time. So if the speed is changing, that means the final velocity and initial velocity, they are not equal. So again, do you remember what is acceleration? Acceleration is final velocity minus initial velocity by time. If the final velocity and initial velocity, they are not equal, then what will happen? If these two are not equal, that means this one is not equal to 0. So that means there is an accelerated motion. So wherever you see a non-uniform motion, that is nothing but accelerated motion. The body will either gain the speed or lose the speed, right? So the rate of change of velocities in a non-uniform motion is not 0. That means it is an accelerated motion. Clear? Alright, velocity is not constant. So change in the velocity is non-zero. So change in velocity is nothing but our acceleration. Alright? Yeah, let him give. I don't care. Let him eat whatever. Do whatever you want. I am just doing my job. So focus on your job. Whatever job you do, it will tell you what kind of characteristics you have, right? So it's okay. Let anyone do whatever they want. Alright. So now what is acceleration? It is nothing but change in velocity divided by total time taken. So that means acceleration is this formula. Remember this formula. A lot of questions, direct questions will come from this formula. What is V? V is the final velocity, U is the initial velocity, T is the time taken, and A is the acceleration. But here you need to remember acceleration and velocity, they are vector quantities. So how will you write this equation in a vector form? So you can write acceleration vector as velocity vector. This is a final velocity vector minus initial velocity vector divided by time. So there is a vector subtraction of two vectors. Okay. So you need to consider the direction as well, not just the magnitude. Most of the times object is moving along a straight line. If the object is moving along a straight line, then you can ignore this vector sign and you can use this equation. But if the object is not moving in the straight line, then we'll have to use this vector formula. Clear? Yes, you have to use the arrow if the object is not moving on a straight line. If it is moving on the straight line, then you can use this formula. But if it is not moving, for example, let's suppose there is the initial velocity U is, let's suppose 5 meters per second. And something happened, this car take a turn. If the car take a turn, now car started moving in this direction. So the final velocity V is again, let's suppose 5 meter per second, right? The magnitude of the velocity is same. Magnitude of final velocity and initial velocity, they are same, but their direction is not same. And because of that, V is not equal to U. V is not equal to U. Even though the magnitude is same, but their direction is different. So these two vectors, they are not equal. and because of that you can write v minus u vector not equal to 0. If this is not equal to 0, you can divide it with time, and what is this formula? This is nothing but our acceleration. So in that case, acceleration vector is not equal to 0. Clear? Alright, Harsha. There are other channels as well. If you are in 12th, you can go to there is a NEET channel and there is a JEE channel as well. So you can learn from there as well. Okay? Alright, great. So now we need to remember the sign. So acceleration is a vector. So it can be positive, it can be 0, it can be negative as well. And how will you decide what should be the sign of the acceleration? So acceleration is a vector quantity. So A is positive. So when do you call acceleration to be positive? If the acceleration and velocity, these vectors are in the same direction. That means, let's suppose if the object is moving and you apply the force in the same direction, what will happen? Your acceleration and velocity are in the same direction. So if there is an object moving in this direction, so there is a velocity direction. And if you apply the acceleration in the same direction, then the object will gain the speed. So that means this acceleration is positive. And when it is negative, if let's suppose velocity and acceleration, they are in the opposite direction. So when do you see this kind of case? If there is an object is moving in this direction, and let's suppose there is a friction. Because of the friction, there is a frictional force. Because of the friction, acceleration is in the opposite direction. So if the acceleration is in the opposite direction, we say that acceleration is negative. And for all of these, it can be positive, negative, 0. The SI unit is meter per second square, or meter second raised to minus 2. Clear? Easy, right? Easy? Alright. So now let's solve this question, everyone. Solve it. Okay, so what is the question? A car is moving towards east. Okay, Ansh Patel, just give me 2 minutes. I'll clarify. So we'll solve. I'll give you the example when the acceleration is positive or negative. So just 2 minutes after this question. Car is moving towards east. So do you know how the directions will look like? The top direction is usually in the north. There is a south, and here there is a east. This one is west. Clear? So car is moving towards east at a constant speed of 10 kilometers per hour. Right? So let's suppose we have a car here. It is moving in this direction at a speed of 10 kilometers per hour. The car takes a turn, start moving towards south. Now this car here started moving towards south, and what is the speed? Again 10 kilometers per hour at a constant speed of this much. So is there any acceleration? What do you think? No? So you feel that there is no acceleration. That is wrong. Just now I told you the velocity is a vector. So there is an initial velocity u vector, this much. There is a final velocity, or the v vector. So now even though their magnitude is same, their direction is not same. So u is not equal to v, and because of that there is an acceleration. So answer is yes. Just now I told you, right? You guys forgot? Here, see, I told you the similar question. It was 5 meters per second. I proved that acceleration is not 0. Acceleration not equal to 0. That means there is an acceleration. So answer option number B is the correct option. Alright, Srishti, Rudraksh, clear? Any questions, anyone? Now, yes, I was telling you this. So let's solve. If the acceleration is 0, positive and negative, how will the situation look like? So let's do some maths here. What is acceleration? I'll write down here. Acceleration is v minus u divided by time. So let's just substitute this value here. So v minus u divided by time is equal to 0, right? Here I can write the same equation, v minus u divided by time greater than 0, and here v minus u divided by time is less than 0. Now what you do is you multiply both sides by time. So if you multiply both sides by time, you will get v minus u is equal to 0. 0 into any number is going to be 0 only. Acceleration is infinity. So what will happen, Dinesh? Tell me. Here v minus u is greater than 0, and here it would be v minus u is less than 0. Now what you do is take this minus u to other side. So if you take the minus u to other side, you will get v is equal to u. Here what will you get? V greater than u, and here v less than u. So now we got three different situations. If the acceleration is 0, then what will happen? That means the initial velocity and final velocity, they are equal. So that is the example of, uniform motion. Uniform motion. So object is moving in a uniform motion. So there is no change in the velocity. You didn't get the second step. Which step you didn't get, Rudraksh? Here from this to this you understood. Multiply both sides, left side and right side, by time. So if you multiply the right side, let's suppose multiply both sides by time. So this t will get cancelled out, and 0 multiplied by time is 0 only, right? So from here, how did you get this step? This minus u, you take it to the other side. When you take the minus u to the other side, what will happen? The sign will change. This minus u became plus u. So that is why v is equal to u. And exactly same thing I have done to both these cases. Clear? Alright. Yeah, oh sorry. Here there is a uniform motion. How about this? If the acceleration is positive, when the acceleration is positive, then what happened? The final velocity is greater than initial velocity. So the object is gaining the speed. The speed is increasing continuously. And here, if the acceleration is negative, then the final velocity is less than initial velocity. So object is slowing down. So it is getting faster here, getting faster, and here it is slowing down. Right? So that is the meaning of negative acceleration. So this is also called as retardation. Why it is called as retardation? Because object is slowing down. So whenever the acceleration is negative, it is a retardation. That means object will slow down. Clear? Solve this question, everyone. So question is, what is the value of acceleration for the uniform motion? If it is uniform motion, which of the following is true? Is acceleration positive, acceleration equal to 0, or negative? Uniform motion. Just now I solved this question. Na? If it is uniform motion, it is this for the uniform motion. So what is the correct answer? Nice, Ansh and Srishti. Acceleration is equal to 0. Awesome. You guys are great. Yes, Rudraksh, correct. Next question. A bus decreases speed from 36 kilometers per hour to 18 kilometers per hour in 5 seconds. So find the acceleration of the bus. So how will you find the acceleration of the bus? There is a change in the speed. The speed has reduced. So you have to calculate the acceleration. Hi Padmini. Yes, nice beta, correct. So let's write down the initial speed u is 36 kilometers per hour. Final speed v is 18 kilometers per hour. And what is time? Time is 5 seconds. Okay, nice Padmini, Ansh, Rudraksh. So here this is kilometer per hour. This is not the SI unit. How will you convert it into SI unit? How will you convert? You just have to multiply by a factor. So this is 36. You multiply it by 5 by 18. So that number will become in meter per second. Similarly, this is 18 multiplied by 5 by 18. This would be in meters per second. So now we need to simplify. This 18 into 1, 18 into 2, 18 into 1, 18 into 1. So what will be this? 2 into 5 is 10 meters per second, and this 1 into 5, which is 5 meters per second. So we know the initial velocity as 10, final velocity as 5, and there is a time. Yes, Rudraksh, correct. So what should be the answer? So now acceleration is nothing but final velocity minus initial velocity by time. What is the final velocity? Final velocity v is 5. So it is 5 minus 10 divided by 5. These many meter per second square, which is 5 minus 10 is minus 5 divided by 5 is minus 1 meter per second square, or second raised to minus 2. So that is the value of your acceleration. Clear? How many of you find it easy? Very very simple. Very easy, right? Is there anyone who find it difficult? Alright. So now we have learnt uniform acceleration. What is uniform acceleration? Uniform acceleration means the acceleration is not changing with time. Acceleration value is constant. Uniform is nothing but constant acceleration value. So the acceleration is not changing with time. And what is a non-uniform? There is a non-uniform acceleration. That means the value of the acceleration is changing with time. So this is the acceleration changing with time. That is the meaning of non-uniform acceleration. So let's find out few more differences. Uniform acceleration, acceleration do not change with time. Non-uniform, the acceleration changes with time. Uniform acceleration, velocity changes at a uniform rate. The change in the velocity is uniform. Change in the velocity is uniform. Here the velocity changes at a non-uniform rate. So change in the velocity is not uniform. An example of uniform acceleration is motion of a freely falling object. Do you know what is freely falling object? If I just drop this object, this device, it will fall. Sorry. So that is a freely falling motion. If the object is falling under the gravity, there is a free fall or freely falling object, right? And what is a non-uniform motion? There is like all the other motions. Let's suppose you are driving a car or bike. There are a lot of signals, traffic lights, right? So what will happen? Hi Shweta, good afternoon. So there are a lot of traffic lights. So what will happen? You will, when you see the red light, you will apply the brake. If you see the green light, you will accelerate, you will raise the car, right? So that is an example of non-uniform acceleration. Okay. So let's solve one more question based on this. Solve this. Okay, so here we have a graph. There is a velocity versus time graph. Velocity versus time graph, and what we want to find out, which of the curve below figure represent a non-uniform acceleration. D, nice. Shweta and Rudraksh, nice, great. So okay, the easier one, let's start with the easiest or easier one. So here this B, this is a flat line. So there is a, what is this? Velocity. So the velocity is fixed. Velocity is not changing with time for this graph B, this segment B. So in this case, the acceleration is 0. Acceleration is not changing with time. How about A? There is a straight line. A is a straight line. That means it is a positive acceleration. Straight line going up. You see the velocity is increasing. Velocity is increasing with time. So there is a positive is constant and positive. So acceleration value is constant and it is positive. How about this segment C here? This one here, this one here. So in this case, again there is a straight line, but it is going down. So velocity is reducing with time. So for this, we can say acceleration is constant and acceleration is negative because velocity is reducing with time. And the last one, this one, here you see the velocity. The change in the velocity is not constant. Hi, Virutham Bal. Yes, good afternoon. So the rate of change of velocity is not constant for this last curve. So what does that tell you? It tells you that the acceleration is non-uniform. So acceleration here, acceleration is not constant. Not constant means it is non-uniform. So which of the option is correct? It is this option number D. For this, acceleration is non-uniform. That is the correct value. Yes, this part C is the retardation. Retardation is simply if the acceleration is negative, that is retardation. Okay? Acceleration positive, that means body will gain the speed. Speed will increase. Acceleration negative means the speed will decrease. That is the retardation. Okay? Retardation is different from non-uniform motion. Non-uniform means it is not constant. It will change with time. You see here, for this graph D, acceleration is changing with time. Clear? Alright, so that's it for today. Thank you so much everyone. Bye-bye. Enjoy, have fun, take care, and see you again in the next class. We are going to learn about graph, different type of graph, distance versus time graph and the velocity versus time graph. Alright. Hi, classy. Bye-bye. Take care.